we decided very early on that the way to win is for Spark to win. The first goal was Spark to win at all costs. A few months after we started, we had a partnership with Cloudera. I remember that some of the PM was telling me, we are stupid to do that because Cloudera will just learn how to deploy and set up Spark on their offering. And then, what you are going to do. But it was okay because always we saw that if Spark wins, then we are going to be able to make the best product for Spark, and eventually Spark users are going to come to us because we are going to make the best product. And if we are not making the best product, well, we deserve to lose, right?
Thank you so much, all of you, for being here today. I'm going to keep the introduction short and sort of dive relatively quickly in. But I think the thing for me that stands out here is so much of what we do in technology starts in university labs. So many professors start with a lab and then eventually that research goes on to become a company. I think what is unique and rare in Jan's case is that he's founded 3 such labs. The AMP Lab, RISE Lab, most recently the Sky Computing Lab. There's at least 3 companies that I'm involved with that he has co-founded. Conviva, Databricks, and Anyscale. I think you're also the founder/father of at least another half a dozen companies. So there's, at this point, almost 10 companies that have come out of those 3 labs collectively. And Jan tells me it's just the beginning. There's a handful more coming. He isn't done with disrupting the software stack. So that's Jan. I think the thing that I've had the opportunity to work with Jan for the last 17 years. And the thing that's always blown me away is how he's able to take something that in the moment feels non-consensus or not obvious and state it in such simple terms that I've always left thinking, hey, that feels so obvious. And then I walk away. I'm not sure I'm able to replicate what he said in the moment. But years later, it becomes the basis for something that is going to be more than just a company. Very often, it's a more fundamental trend in technology. And so that anyway, and hopefully we will have Jan share some of those, what he's seeing sort of going forward today. But before we dive into that, we're going to sort of zoom into both some of the technical insights and the experience he's had as a founder who started off as a professor, and also talk about sort of his journey as an entrepreneur and what it's been like to go from being a professor to a technical founder to a CEO of some of these companies. Thank you very much, Jan, for joining us.
Thanks for having me.
Let me go back to the beginning. If you go back, did you always start off thinking that you would be an academic turned entrepreneur? How did this whole journey start?
So actually, early on I came to academia. I always, is something as a principle, I want always to maximize my optionalities. And when I graduated from CMU, I thought, okay, what I can do, I actually graduated in 2000. And as maybe you read or you know, 2000 was...
Some of us are old enough.
Is that now? It was the height of the .com. And then a few months after it went south. So actually when I graduated, it was extremely hot. It's like today internet. At that time was internet. Just to give you a sense, I think that Amazon was founded in 96 during my PhD.
Yes.
I think VMware in 97, and all this, and Akamai also around that time, which Akamai, I don't know if you remember it. Also during my PhD went public in less than 2 years at 16 or 17 billion valuation. So just to give you a sense about what kind of euphoria were there. So it's, and but then when I thought about and actually Hui, my advisor back then, went to a company, Turing Networks. He was, I did my PhD in networking, right? Internet. So it was like today AI. And I just thought about what I'm going to do next. And I thought, it's like, if I'm going to go to academia, I can go to start a company. If I go to start a company, it's going to be harder to come back to academia. So that's about optionality. And yeah, so that's pretty much it. And of course, why academia? I really like to explore, to, to start new projects, to not have anyone to report to. Yeah.
Well, maybe we just, I'm tempted to go back all the way to the founding story of Conviva, but just in the interest of time, maybe start with the founding story of Spark itself, the project,
Yeah.
and how Spark then eventually became Databricks.
So one thing I also in my career, I want to say is that as academic and in general, but you take it for granted. In academy, it's harder. I was pretty opportunist, right? In the sense that I changed my focus every couple of years. I started with the internet, then I did peer-to-peer, I did big data, then AI systems, AI and so forth, cloud computing. So as you can see, I am saying opportunist because I'm coming kind of moving along with the hottest whatever trends. But the reason I'm saying that, because that's kind of explained a little bit, Conviva was built around the idea as a peer-to-peer at that time. The consensus was that we are going to move to video, sending video over the internet, and the internet will crash and burn. It's not going to support the video. We are wrong about that, but that was kind of the main idea, and it was at that time, this was, so basically, instead of hosting the video somewhere in some data centers and getting the video crossing the internet to come to you, you have a lot of peers which maybe have the video, and then you get the video from someone nearby, so you don't need to go through the internet backbone. That was kind of the main idea. But then I think that, it was the rise of the, Conviva was 2006 founded. Then in 2009 was this kind of big data. There are a few things. One, Conviva, what was doing at that time was doing one of the products. It was providing real-time analytics for the video. Whether there are problems, what are the problems, and the product being sold to content providers, including content distribution network at that time. And that was about processing the data, a lot of data, and more kind of real time as the data comes in. And there are two paths kind of led to Spark. So one was this path. So basically saying, and we are having we are using a database, MySQL at that time, to implement this kind of, more real-time querying, more in real-time of the data, and you put the data in database, and then you can query it. But then we are scaling at that time quite fast, and I remember distinctly this point in which we are, everything was on-prem then. There were no clouds or it's early on, so we have our own data center.
We had our own data centers. We had server builds. I remember those.
And then I remember that we were ordering the new hardware because we wanted to scale. And the largest machines then we could do it, and there are a few of them because we were already trying to do it a little bit distributed. And I remember that by the time they came, we were already over. And then the idea was to do it. I'm not sure I actually remember. I said, okay, why don't we instead of, because there you need to say what is the number of users and where is the user located and so forth. And there the question was about, okay, we cannot answer these questions with the hardware we have. Precisely, what if we do some approximation? Do some approximation, right? You can do approximate queries, and instead of all the data, you consider a sample of the data, you get a result, and yes, you can say what is the error. So I remember, so I said it's obvious because the way we collected the data was from every client to send these Harbies to our backend. And the loss in the Harbies, because the internet, is not fully reliable, was, in some sense, was introducing a bigger error than this approximation. So I thought it's no-brainer. So I go to our PMs and say, and I was thinking about, okay, how we are going to visualize, because it's still an error. You want to look at the customer, say, okay, we put some kind of bars around the real value, and say, no, absolutely not. And then my mistake there, because I insisted to have this kind of bars and visualization, because the answer would have been, forget about bars, just show the numbers. Anyway, it's approximate to start this, right? But I didn't do that, so I couldn't get. So in some sense, actually, we took the functionality out from our product to get this in real time. Okay, so that's kind of one thing. And then we have this kind of Hadoop stack, because that was scaling. MySQL didn't scale, but Hadoop was very slow. No, real time. So that's kind of, I was very frustrated at that time, because we don't have something, we are going to have much faster queries. So that's one thing. The other thing was happening at that time, you mentioned about AMP Lab. We have people from AMP, it was standing for algorithms, machine, and people. Algorithms are more AI at that time. There was this kind of Netflix challenge. How many of you remember about the different Netflix challenge? Okay. So it was Netflix challenge, and we have machine learning people in the lab. It was Mike Jordan was part of the lab, and they wanted to compete for this challenge. And they come to us, and Matei was there, it's like, and say, okay, what we should do, because, we want to implement this collaborative filtering. And say, okay, you do Hadoop, because you're already working, people Hadoop and so forth. News of people from Yahoo, Eric 14 and so forth, we are pretty much friends. And then they say, or they take Hadoop, and they come and say, man, it's so slow, right? And obviously it's so slow because machine learning is iterative, right? You start with a solution and you can iterate to converge to a model which provides you with performance. Each iteration you have to read and write the data from the disk. And then, Mateo was kind of working with Mateo, my student at that time, and put together a very simple, few thousand lines of code back then. To solve that problem, and the way to solve the problem is keep the data in memory, right? And it turns out that, contrary to the popular belief, then a lot of data, for a lot of use cases, the data actually fits in memory. So if it fits in memory, you can do much faster. You do query much faster, you can do machine learning much faster. So that's kind of was how Spark was built to solve this kind of problems. Real-time query processing, machine learning workloads.
So my more simplistic memory of this was, I remember the board meeting when we decided to take that feature out.
Yes.
And then I remember the next board meeting when Jan came back and said, oh, I had this summer intern, he wrote this new piece of open source code, and now we can put this back in production. And that piece of open source code that he wrote over I think 30 days, if even that, was what eventually became Spark. Yeah, moving on from sort of the project itself, when you think about sort of the incredible journey of Databricks itself as a company, are there one or two decisions that you think are sort of some of the most seminal decisions the company made in early years that weren't obvious then and would generally be considered obvious in consensus today?
Yeah, so there are a few of them. Maybe I will go to, I'm going to mention three things. One, starting the company. We are not very clear to start the company, whether you want to start the company. What happened is that at that point, Spark was becoming more and more popular, and some companies are starting to use it and build things on top of it. And they were asking who the head is going to support, who is going to, what happens, what is the future of Spark? Right, what happens is that other students graduating, what happens, right? So initially, I said a story quite a few times, we went to one of these cloud Hadoop providers, Hadoop companies. At that time, Cloudera, Horton, or whatever. And we actually asked them whether they want to take over Spark and maintain it. Okay. And they said no. because they have an internal product.
Yard.
Not yard. Yard knows more of the last, I'm not going to say because I identify the company.
Yeah.
So you say no. So then I say, okay, I was at a point, of 6 years after starting
Conviva.
Conviva or something like that, 7 years, and can take another leave or sabbatical. And Mateo was graduating, and we have Ali was there, and we have another few students, which are Patrick and Wendell and Andy Kobiski, which they wanted actually in parallel to start the company on Spark. So we had and then Reynold, who was doing a bit, we were working with us on database and have this Sharp, which is a SQL kind of interface on top of Spark. So we have this kind of signals like we can start a company, right? That's what we start, how we start the company. So that's the first one, deciding to start a company. The second one, which I believe it's about being really focused in terms of the market we wanted to address, right? At that time, we are focused on data scientists building a tool for data scientists to process the data at scale, right? That was it. And the reason that was, it was not maybe the most obvious decision. There were not a lot of data scientists at that time. However, what we knew and what was kind of the bet was that at that time, almost every university was starting to provide degrees for data scientists, right? So you could see that kind of market growing, right? That's the second one. And that was pretty consequential because that meant that we had to build a pretty elaborated product. It took us 2 years to build a product. We released it in June 2015, the product, and we started the company in end of May 2013, officially. We are working with the company even earlier. And the third one is the cloud, right? I was saying we focus on the cloud. And that was probably the hardest decision because Cloudera, as the name implies, Cloudera, was targeting the cloud. They started in 2009, 4 years before us. But they pivoted to on-prem, and they were hugely successful by doing so. Okay, so now you go and say, we want to do in the cloud, but hey, this company, which is in your space, it's big data, try cloud, and pivoted to on-prem, and they are hugely successful. So why would you go there? There are a couple of reasons to go there, and so obviously, so one reason to go there was that, in some sense, one, there are things which pulls you to the cloud and things which are kind of push you to the cloud. It's push, right? So one of the things which pushes us to the cloud is that the Cloudera and Hortonworks are very successful on-prem. And Spark, it's only the compute engine of the big data. It's not the storage. Hadoop has both storage, HDFS, and the compute. We are replacing the compute, the memory use. So it didn't, if you go on-prem, you have to have a full solution. Either you have a full solution, so you need to have a storage system or get on, or maybe take HDFS, or go on top of Cloudera and Hortonworks, right? But that was kind of difficult because he didn't tell the customer and things like that. That's so push, right? The pull from the clouds were the fact that we realized early on that actually if you want to develop both on-prem and then later cloud, there are two different development processes. So you fundamentally need to do two engineering teams, right? And we are not even sure that we can do one well, right? And cloud seems to us as engineers is much easier, right? You have more telemetry, you can upgrade whenever you want, fix issues and things like that, more visibility. So everything, it was easier, we thought. And it was to some degree. Yeah. And we thought that we can do that reasonably well, while on prem, a lot of things at that time were still professional services, and we didn't know how to do that. I mean, you do that, but it didn't seem to us that is very scalable, right? At that time, just to give you a sense, when we started, the biggest success of the open source-based company was Red Hat, around 16 billion, if I remember correctly. The other one were 1 billion or less. It was kind of MySQL, Cloudera at that time. These are kind of what it was there. And all of them was having open core on-prem and so forth. So that is the second, the third one, going to the cloud. The one thing which actually, because there's still a lot of push from many people basically saying that, hey, yes, a cloud, but on-prem, if you are not on-prem, you leave so much money on the table, right? It's like valid. But what made the decision easier, because then I was asking everyone, okay, but which one do you think is going to grow faster, right? And all of them say cloud, but now it's on-prem. And then they were talking about these billions of dollars of market and so forth. And when you do the math, even if the company is rocket ship, at least as time numbers, you see that in order to make a dent in this kind of $1 billion market, it's going to take you 6-7 years, everything going perfectly. At that time was double, triple, double, yeah, right? So 5 years, everything was perfect, right? So you get 100 million revenue at that time for a SaaS company, yeah, right? So you look at that, okay, so instead, instead of going to on-prem, I can go on cloud, and if cloud, everyone agrees that it's going to grow faster, then it's enough market. Yeah.
Right. If you can get even 100 million in 5 years, it's big enough market for you.
It's actually it was still enough market because we have EMR from AWS, which was providing already a hosted Spark. And they were having, I don't remember, it was 2014 or something like that, already having 200-300 million revenue. So it was a no-brainer, right? And actually, I mentioned also about this kind of niche because when we have the data science, right, data science at scale. Because the easiest way is to identify a niche, dominate the niche, and hopefully you made the right bet that the niche is going to grow very fast. Because if you dominate the niche, then you are going to grow with the market, with that niche, right? If it's growing fast, right? It's very simple. And we are looking at all these kind of big companies and convince ourselves that actually that's always, happened with Microsoft, with IBM early on, with Oracle early on. All these companies started with a niche, right? It's also, by the way, it's much easier to dominate a niche than a big market, right? Because for a big market, you have incumbents. Incumbents don't care about the niche because even if they dominate the niche, it doesn't move.
It's not worth their time. I'm going to switch from the technology to sort of your experience as a CEO, because you were the founding CEO at Databricks for a very meaningful period of time, and that was your first time as CEO. What are the things you had to learn making that transition from being a technologist to a CEO, and perhaps what are the things that you had to unlearn?
You learn very fast that, although you know that as an academic, but probably I didn't realize as much. Everything is about the people, right? I found myself spending all my time with people, and and the big problems always all about people and things like that. And so that's number one. The number two, you need to get from this mode in which, as academic and so forth, you have all these smart students, and you basically say, okay, I am going to hire the smartest guys, and they are going to learn. And it's truth to that. But then you realize that actually if you hire people with experience, in many cases it's better. also these people are much easier to manage, right? Because they know it, right? They have seen it, right? So I think going to this mode and just focusing on getting people with experience to help you and you learn from them, I think was another transition than as, like just hiring the smartest kid out there, right? So I think that was the second one. The third one, it is, at the end of the day, you need to be the cheerleader, right? Because, like I mentioned to you, in the first I was CEO for almost the first 3 years. It wasn't easy because you go on-prem. So here is the things, right? You think about Spark, very popular, okay? Now, one decision we made, it's another decision we made, which I am really proud. We decided very early on that the way to win is for Spark to win. And so the first goal was Spark to win at all costs. So this meant that, for instance, a few months after we started, we had a partnership with Cloudera. It was revenue sharing. And Cloudera was eventually, competitor. They didn't know what we are doing, but they are providing Spark on on-prem, and they were talking that we are going to do cloud as well at some point. And that was a hard decision. I remember that some of the PM was telling me, we are stupid to do that because Cloudera will just learn how to deploy and serve Spark on their offering, and then what you are going to do. But it was okay because always we saw that if Spark wins, then we are going to be able to make the best product for Spark, and eventually Spark users are going to come to us because we are going to make the best product. And if you are not making the best product, well, we deserve to lose, right? Because we are the people behind Spark, right? So that's kind of, just to give you some more context. And we did that with Horton, Onyx partnership, DataStars, and many others, helping them to promote Spark and to sell Spark to customers. With Cloudera, we had a level 3 and level 4 support. And we knew from the beginning that they want just to learn how to support Spark, and it was very clear. So you have this one. It's again, we are focusing on building this kind of integrated product for data scientists, notebooks for class management. So as you go ahead, now fast forward to 2015, before we release, we don't have much revenue, we haven't released a product. And then you have all of these companies making a lot of money out of Spark. You have, on the clouds, you have AWS with EMR. And you have Cloudera, make millions and millions with Spark, Horton, and so forth. So you make almost zero. So it's a lot of pressure, right? How do you do that? So, and when we started, even after we started in 2015, and we got a lot of customers. In the 6 months, we got like close to 300 customers. But the ASP was very small, 14K, 17K, SMB, like imagine this, the sales cycle is also short, right? So we have also a lot of customers, and we have an ARR, I remember like 2015, 3.5 million. We just hired our sales guy, Ron Gabrisco, which is still today there. And then, it's a lot of pressure, right? And you have this, you launch it, 3.5 million ARR, these guys are making 10 times more at least, right? So you need to keep that belief, right? Is that despite that, you still need to keep focus, you need to keep the, obviously the, we did have help from the board, and I should, they were obviously supportive, but, it's like the company is like to keep, it wasn't obvious because people are saying, okay, look at these guys, they get a lot of money out of Spark, what are you going to do, right? So I think that's what I mean by cheerleaders and just push
Yeah,
forward.
keeping things together and keeping people sort of motivated and aligned. I could probably spend another hour talking about Databricks, but I'm going to keep moving along and maybe fast forward to your story at Anyscale, which is a very different company and started with a very different context. Maybe you can talk a little bit about that and sort of maybe in particular talk about what was different in the Anyscale journey and what were some of the lessons you learned there, which were different lessons from the Databricks lessons.
Yeah, I think, look, in the company like Databricks, is, like everything worked. Something clicked, like it's the right technology at the right time. We had luck because Hadoop, also companies were, there was competition between Cloudera and Hortonworks, and I think that slowed down both of them. Maybe other competitors made mistakes. So it was a combination, right? We executed reasonably well, and but it's a lot of things going on, and something depends on you, and something will not depend on you. That's why when people say about product market fit, what is the more, PMF, what is the most important is the market. Like if the market is not there, you cannot raise the market, right? Then people and the product. So the way I would say, the simplest sentence I would say is that both companies were built on open source software coming out of Berkeley. One was Spark, the other was Ray. The difference is that one was a second system. Spark was the second system, Ray was the first system. Hadoop was the first system in the big data. Ray was Spark was the second one. And a company which is doing fantastically well with this kind of being second product in the market, it's Apple. Like smartphones, iPod, LP, player, it's like. And
Eventually, Apple Intelligence.
Yeah,
Maybe another 5 years.
Apple Intelligence. So I think that's, because you see about what the first system has done, and you have the hindsight to build hopefully a better system. Now, we need to be lucky so the first system, people behind the first system can execute a little bit, that gives you an opening. But Ray was the first system, and that kind of a little bit ahead of its time. So that was just the thing, right? It's like Ray, it's about scaling machine learning workloads, very general and so forth. So when you have the first system, there is no way around but to create the category. Didn't realize that, right? Because they didn't realize as much the importance of marketing, because we saw that, we thought we did great marketing, but part of the marketing creating the category was not done by us, was done by Cloudera and Hortonworks. And you always, when you are successful, you attribute yourself more credit than you should. And you failed is the other way around. So that's kind of one of the big things. So in some sense, you have to wait for the market, in some sense, to catch up. Because we had, early on, after 2 years or so, OpenAI adopted it and so forth, had this kind of big use cases, but it wasn't prevalent, the use case. So you have to wait now to catch up. Now it happened. Waiting 4 years, so it's good that we raise enough money. So, but that's one. That's one of the biggest lessons and differences.
I'm going to fast forward to today and talk a little bit about the future, maybe one or two questions, and I'll sort of pass it around for the audience. As you think about sort of the world today, what in your mind is blinding the obvious, which many of us in the room might disagree with?
I don't know. I mean,
I had to put you on the spot.
Yeah. I think that maybe the most controversial, I would say, is that if things do not change in the way we do things in the US, it's quite likely that in 1 year, the best models will be built, will be the open source models coming from China. And I'm not talking only about open source, I'm also talking about the proprietary models in the US. Maybe not, they'll not be better, but very close, almost indistinguishable. That will be one. And now you can think about the implications, right? But that's on. The only other thing I would say is that probably in my mind the biggest problem today for AI, it's about reliability, robustness. How you make sure that AI is working. Another one I would say we're discussing at the table. I think that people, it's under, when they look at the success of AI being used as code assistant, they underestimate. They always think about, okay, this is working for software engineering, I'm going to replicate for other professions. But I don't think this will be easy. And there are a few reasons for that. But two reasons which are more subtle, I think, in my mind is like, one is that the code assistant is already, it fits in the workflow of the developer. The developers, they use IDs for the longest time. You have autocompletes and other URLs for a long time. So this is kind of turbocharged those. But I don't need to change the way I'm working. Fundamental. It's shortcuts. Sometimes I don't need to go to Stack Overflow or whatever to see how things are. To solve a particular problem or to remember some of the APIs or I need to use. And the second thing is that the software developers are they are very early adopters of new technology, right? So we have these two things. But if you think about other professions, finance or doctors or something like that, it's not, it's much harder to fit in their workflows. And they are not early adopters, right? So you have to fit, if you do an AI product for those people, for these other professions, it has to fit in their current existing workflows.
So integrating into their workflows, and then obviously still dealing with the fact that they're not early adopters of technology.
Yep.
That's not going to go away. I'm going to, pause in terms of my questions and sort of open the floor. If you stand up, give us a question. I'll repeat the question just to make sure everyone hears it. But go on.
I just have a follow-up question to that. So when you say it's difficult, like how difficult it is, how many years, how big is the gap, do you think, to make AI work for financial professions?
So the question is, Jan made the comment that getting people other than software developers to adopt AI is going to be difficult. And I think you took the specific example of finance. I don't know if, Jan, you have an opinion on that. But how long do you think it would take for finance professionals to adopt AI?
So it's, this generation, is AI we are using today is also called generative AI, right? And the pattern which works, which people are successful today, is that for things which are, where it's hard to generate a solution, but it's easy to check, okay? This is like, if you think about even code, right? Because with coding, the programmer has to check. At least it's assumed that he is going to check, right? If there are problems, it's not cursor liable, is a developer, liable. Or the other things which are not, like image generation, like very hard to generate for you, but easy to say is good or bad, right? For what my purpose. These are the excellent, or customer support, it's another one, which is, I ask you a question, you tell me, oh, I have a problem, I ask you the question, you say, okay, do this in order to solve it, and, check whether your computer is plugged in. And I say, no, yeah, it's plugged in. And give me another suggestions, and we continue that until after a few rounds, if doesn't solve my problem, is they are going to default to a human. These are good patterns. But you are asking about if I cannot have that ability, the other angle, like for instance, let me give you another, legal, right? We know that some, law firms and so forth, they don't let their employees to use AI. But it depends, because there are legitimate uses of AI. Like for instance, in US, the legal system is based on precedent, right? So in many cases, I want to look at similar cases. So that AI is good just to look for all the cases and give me some cases which
Which are precedents. Yeah.
it believes that a precedent, but ultimately I'm going to check, and it's still helping me because instead for me goes through all of these cases and search, I get already a subset of cases, and then I'm going to look through them, and maybe some of them will be relevant, some of them will be. But that's what is the thing. If you don't have a way to verify today, it's very hard, right? And if you know, of course you followed, and there is an article I think 2 days ago in New York Times, and actually the correctness or the hallucinations of the models hasn't improved. In fact, with the reasoning task, it's getting a little bit worse. So, in order to trust them blindly for very important things, it's, I don't know, it will take some time. It will be case by case. I think that you are going to see cases, this is the opportunity for providing good, reliable AI for certain use cases. I think that's an opportunity.
I'm going to keep this going. Next question, please. Anand.
Jan, Ashu said you have founded many companies. We talked about Conviva, Databricks, Anyscale, all great companies. One company I'm familiar with that the other company that you founded is OPAQUE Computing, and I know about them because we compete with them in the space of confidential computing. So maybe you can tell about that company, what's the thesis for that, and how does it solve the problem around the intersection of AI and security, and what you're doing over there.
Yeah. So the thesis of the company, OPAQUE, at the beginning, which is, is one of my colleagues and her students that I look up OPA. It is about this confidential computing that you can do, process the data and query data which is encrypted and get the results. That's basically the way the things about it. So instead of needing to have the data in clear to query it, the data is encrypted. And there are different techniques, one of them, hardware enclaves and things like that. That was the thing. That is about how we are going to do analytics and so forth. Right now, of course, with AI, the same thing is like, try to develop new technologies, which basically is like, so what is the problem today? I want to use OpenAI, but I don't want OpenAI to see I don't want to send the data to OpenAI, right? Because it's confidential. So how do you do that? So maybe you can have a gateway in between that is going to you can send the query, is going to scrap all the confidential information, is going to send it to OpenAI, is going to get the answer, is going to add back the confidential without information, the answer, things like that. But that's the question always is about, in that case, how you allow OpenAI to process confidential data.
Thank you. Ishan?
Yeah, so I'm curious about cognitive work you're doing at Skylab, and also just broadly, how do you think about the infrastructure and baseline infrastructure evolving? So there's an interesting reversal which is happening where, in 2000 you were trying to build DPS systems, and then we realized, okay, that's not going to scale beyond a point. We need to build distributed systems. That's the Ogle took and many other, Hadoop took, your took was part. And now we're actually back towards deeply integrated, high performance Blackwell systems that now NVIDIA is shipping, right, to get the performance we need. So are we going to stay there? Or are we going to move to?
I have to repeat the question, so you need to keep it short enough that I can. My cache is overflowing at this point.
Okay, perfect. What is the future of infrastructure and systems? Are you going to centralize again? Are you going to distribute it? Things like that.
So the question is around the future of infrastructure. We went from centralized to decentralized. Blackwell is starting to is an example of centralization once again. Where do you see the future of infrastructure?
So I think clearly the trends have been for a while, it's about distributed and heterogeneity, right? And that was because the requirements of the workloads grew faster than the capabilities of a single node. And then you can fill that gap in two ways, using more nodes for your workload or building accelerators to close a gap for a single node performance for that particular workload. That was pretty clear as of first. I think that is going to heterogeneity and distribution is going to continue to play an important role. And the reason is that the only workload actually is very irregular. It's training. But when you look at the entire pipeline of this application, you have multimodal data processing, then you have training, then you have inference, and now you have post-training. And if you look at the pattern of these workloads, it's much more complicated. Even if you look about even training and so forth, what is the rule of the game? The rule of the game, I think that for building and building of software infrastructure is basically to maximize the usage of the GPUs, which are the most expensive resources. This is what always you want to do, right? But then if you want to do that, to maximize the usage of the most expensive resources, it's very hard to build a system which is not heterogeneous, right? Because you need, for instance, to feed the data in, right? So you need, to feed the data in means a lot of more I/O bandwidth and so forth. So probably you are going to use more CPUs or something like that. Even something like simple as, even if you serve one model, right, then you have prefill and decoding, which have very different characteristics, right? One is more compute bounding, more is memory bounding. They just for serving the same request. Think about also if you look at multimodal. We are looking at that, and now a lot of multimodals also use transformers. So you can use a high-end GPU for transformers, but also part of the processing of one, even forward and backward pass, even for forward pass, you are going to have to compute the embeddings for its video or images. So it's encoding and decoding. And encoding and decoding, you still want to use the GPUs, but you don't need to use the most powerful GPUs because you cannot use them. The utilization will be low. So now, even in this simple case, you are going to end up with powerful GPUs doing the, running the transformer, and decoding can be on lower-end GPUs. So that's what it is, right? It's like, I think heterogeneity will play. Now, and one other thing I want to say is that indeed, what we are seeing is a much more vertical integrated stack. But this is about phenomenal. Whether you are going to integrate the stack and co-design and optimize the different layers by having more information leaking from one layer to another is different from whether, that you are going to use heterogeneous distributed hardware.
Mohit?
So you expressed concern that China might be getting ahead in terms of AI models and stuff. In your mind, what can US do better to not let them happen?
So the question is about the concern that China is getting ahead or might be getting ahead. So what would you recommend? Yeah.
So you try to think about what are the causes. And again, I'm stating facts here. I mean, if you look at the progress of the open source, which was mainly driven by China for the past year, it was much quicker than the rate of growth of the best proprietary models in the US. That's a fact, okay? And you think about why happened that. There are many reasons. I mean, one angle to look at that is from what do you need? You need experts, people, you need data, we need hardware. And for the first two, China is pretty good. They have a lot of experts, they have a lot of data, arguably more than US for obvious reasons. Not good, necessarily good reason, but the fact is it helps, you know. The only thing they don't have as much is hardware. But again, export controls. From my personal experience, I grew in Romania, communist Romania, and I remember there were export controls for Intel chips, high-end Intel chips. I don't think they were very
successful.
very successful. Yeah. So I don't know that, but I think that the other thing is about, which I'm going to get to, and because I didn't provide any solution. I think fundamentally what happened in China, the diffusion of innovation is much higher than US. Because among many labs, they are doing these open waste models. It's not only that, you know, they are starting to release the software stack, like Bank does. And also they are working much closely with the universities. If you look at DeepSeek, works very closely and have a lot of Beijing and students from Beijing University and Tsinghua University. While in US, everything is very siloed. Every company or big lab is pretty secretive. There is very little collaboration between these labs and academia. And academia itself doesn't have the resources because there is no collaboration with these labs in terms of the infrastructures. No, to be competitive. And I want to point this out, where the infrastructure is not the bottleneck, academia is doing very well. You know, if you look at Spark, Ray, and even inference, AI, large language models, the most successful open source systems are coming from academia and techniques. It's VLLM, HLM, the most popular systems. And then if you look at techniques like flash attention, page attention, specking, and many are coming from academia. So this is what you lose. Because in developing new models and so forth, you know, that academia and research community cannot play a significant role. The only diffusion of innovation what happens is people leaving from our company going to another company or starting new companies.
Yeah. Just a minor anecdote on sort of the GPUs. The largest market for NVIDIA is Singapore, tiny little island. The second largest market is Malaysia, and the US is the third largest market. So think where all those GPUs are going. Really?
Many of you know here that this like a question comes from like personal place, but building a platform business. So you mentioned that building Databricks to like a number of years in the beginning, like a significant revenue, the same thing like with Anyscale. Now, like if you were to start Databricks today, in today's climate, Ashu might tell you that look, Cursor like got to 300 million ARR in 9 months or whatever.
So you got to get to it in 8 months.
Yeah, exactly. So what do you think about building platform businesses overall? I mean, it's harder.
The question from Vinay is, how do you think about building platform businesses in today's market?
Yeah. I think definitely you need to find the right investors, indeed. I think that the main question here is about building, you know, like our CEO and our Anyscale is saying durable growth, right? Obviously, you know, you can get much quicker and faster revenue today. For me, you know, in some sense, this is not very different from the .com days. In the sense that there, the focus was on a lot of consumers, services, and it was about acquiring a lot of users. The difference is that right now the users pay. Then they didn't pay. And maybe OpenAI conditions them about paying, but that's the difference. But other than that, it's the same, because there is like the same thing, you know, in a few, and there the value was about eyeballs, you know, they are correct, right? But the same thing, you know, is like how fast you can get eyeballs, right? Because eventually everyone saw that, you know, you can convert them in revenue somewhere or another. Now you can get the revenue. But, you know, at the same time, you have to ask yourself, and I'm sure some of these companies will become maybe generational companies, but if a company gets in 8 months from, say, zero from 100 millions, what that says about the amount of that company, right? Right, it's probably, it's like, it's, in most cases, it's not going to be very high. This is also true in the income base.
Yeah.
So I think that we'll see how things are playing out. Again, it's obviously, you cannot ignore the numbers and the facts, but I think things are much more complicated.
We're definitely open for business for platform accountants. I'm going to take one last question, maybe two. I saw two hands go up, so I'll let you go first, Animesh, and then last one here to wrap.
Yeah, so simple question. What was the role of the DBU in capturing the value that Databricks was creating? And was it obvious that that was the way that you were going to do it?
Could you repeat the question?
What was the role of the DBU
What was the role of the DPU?
in capturing the value that Databricks was?
What was the role of the DPU in capturing the value of Databricks?
DPU, GPU, you mean?
Like the Databricks
Processing units.
The Databricks Unit.
Databricks units. I saw. It was not very different from credit. It's just one level of indirection, right? Because you buy Databricks units, and then you can spend them however you want, but for different services, you are going to charge different numbers of Databricks units. The one thing is about even, and again, with credit, you also have one level of indirection, but it's a little bit more obvious. But the one nice things about decoupling, you don't need to change the price of your services. Because the way you are going to do discount to the customer is like even Amazon is doing today or others. You pay me, $80 and I give you $100 of coverage of credits. That's what happens. But it doesn't change how much you pay for an instance and things like that. Yeah. So, and it also provides you more, again, like every indirection, provides you more flexibility, because other than that, you have different prices, for, say, interactive workloads or batch workloads or things like that. If you have different prices, when your customer comes, I want the discount, what you are going to do? You are going to discount what you want, or you are going to different discounts depending on what the customer needs are. It's very complicated. Right. My point is that beyond the Databricks units, having that level of interaction is very, very healthy. Simplifies a lot of things.
You had the last question.
So you've seen a lot of technology sort of rise, and we're now seeing the exponential growth in AI. Do you think that exponential growth will continue almost indefinitely, or does this plateau at some point and then carry on growing? What are your sort of general thoughts on the trend of AI in the next 1, 3, 5 years?
So question was exponential growth of AI today. Jan, do you see that trend continuing, or do you see a plateau ahead of you in the next few years?
I think we are already seeing a kind of a plateau in terms of the model's performance and things like that, right? And it was starting last year with pre-training. Now we are going to do post-training. We are doing test time compute, and this is reasoning. But with the reasoning models, like if you see where you get, and we go back to the reliability aspect, where do you see the big progress with the reasoning models? Problem solving, coding. What do they have in common? It's easier to verify the outputs. You have a ground truth, so you can learn, right? It's much easier to make, like humans. If I have a very precise goal with clear deliverables, you are going to make much rapid progress. Whether that goal is good or bad, that's second time. But I think this is what you see. So you are going to see still a lot of progress, but it's going to be much more piecemeal. It's like different for different tasks and so forth. It's clearly, and what was said in the past, that exhausting the data is going to lead to a plateau, and this has happened. People talk about again about synthetic data, but with synthetic data is the same thing. How do you know that it generates good synthetic data? You need to have a test for that synthetic data. Again, you go for two routes, having the rules, clear rules, or to having ways to verify that the data is kind of correct, right? So I think that it will be harder to get this kind of explosive growth. And some of the reasons is that you need, in order to make a lot of more progress with these new paradigms, that's like compute, you need to have ground truth. You need to know what you want. And we need to test. You have ability to test whether a solution is good or bad. I'm not saying you will not make progress for other tasks, but for this task, it's so much easier to make progress when you have a ground truth. Think about AlphaGo. AlphaGo is in 2017, 8 years ago. It was 5 years almost after the revolution of deep neural networks, 5 years, 2012, is finished that. The neural networks of, doing better than humans. And now, 2017, 2025, it's 8, right? And that was beating the best Go player in the world, right? Considering a very complicated game. But in that case, it's like, you know very clearly whether you own or lost the game, was the game. You know very well the rules of the game, right? So we have a much more constrained action space. Perfect. That should give you an example.
I think the thing I would just add to that, I think while we're seeing some plateauing around the technology trends, I think in terms of adoption, as Jan said earlier, we're literally in the first innings.
Yeah, it's application. Using application.
Yeah. So in terms of the host applications,
Yeah.
I think the hardest part is how do you get the first handful of early adopters to trust the technology, get them to sort of, have the right human in the loop to buy into the technology. I think 99.9% of the adoption is ahead of us.
Yeah, so that's against the application. It's like internet. The internet has remained pretty much unchanged. Early on, it's like, and then
For 30 years. I mean,
Yeah.
not much has changed on the internet in 30 years.
yes, about protocols and everything, right? But of course, in terms of the impact, and it has a tremendous impact. The same thing. My answer was about models and at this level, more infrastructure.
Thank you so much, Jan. Thank you very much.